A ladder 28 feet long rests against a vertical wall. Let's go ahead and sketch that. So if I have a vertical wall, there's the wall. I have a ladder leaning up against it. That ladder is 28 feet long. So let's just jot that down right there. Okay, that's just the first sentence. Let theta be the angle between the top of the ladder and the wall. So theta is here. All right, make sure you label theta correctly. And let x be the distance from the bottom of the ladder to the wall. So there's the distance between the ladder and the wall here. Of course, since it's a vertical wall, this is going to be a right angle, and therefore x will be that length there. If the bottom of the ladder slides away from the wall, okay, so the bottom of the ladder is sliding away from the wall this way. It says, how fast in feet per radian? That's actually really key. Feet per radian. Does x change with respect to theta when theta is pi over 3? Okay, so you have to read that last little bit very carefully. How fast does x, so that distance the bottom of the ladder is from the wall, change with respect to that angle theta, not with respect to time? So it's not going to be a dx over dt. Instead, we need to find dx over d theta. So with that in mind, we need to find the relationship between theta and x. Well, since I have a right triangle, I know this is my hypotenuse, and this side is the opposite side to theta. So which trig function uses the opposite side and the hypotenuse of a right triangle? If you remember SOHCAHTOA, that's going to be your sine function. So all these quantities are related this way. Sine of theta is equal to x over 28. All right. Now, remember, we're looking for dx d theta. And so if I can just get x isolated, then I'll have x equals such and such, and I can differentiate with respect to theta. So if I multiply both sides by 28, I'll have 28 sine theta is equal to x. Okay, now differentiate with respect to theta. So let's scroll down. All right, if I differentiate with respect to theta, well, what's the derivative of 28 sine theta? Well, the derivative of sine theta is cosine theta. So this is going to be 28 cosine theta is equal to dx d theta. So I differentiated x with respect to theta. And now we're looking for dx d theta when theta is pi over 3. So we're going to take that pi over 3, plug it into cosine theta, and then we're just going to calculate. So what's cosine of pi over 3? Well, that's 1/2. So I have 28 times 1/2. And then finally, my answer is going to be 14 feet per radian. There you go. So x is changing by 14 feet per radian. That angle changes. That's how you would interpret this. So as that angle gets bigger by 1 radian, the foot of that ladder is sliding 14 feet away from that wall, right? So the distance is getting greater. So if I scroll back up to the picture, as this angle increases per radian, x is going to increase by 14 feet. So dx d theta is 14 feet per radian. On to the next one.